Good morning. We're going to talk today about mechanical waves or sound waves and how they're a type of energy that affects the world around us. Now, sound is a type of energy. It's a vibrational energy. I want you to take your fingers and touch the speaker of your computer. I have a low pitch tone playing, and you may need to turn up the volume for this, but that is energy. That is the vibration of the speaker, and it's vibrating the piece of plastic or metal that's on your computer speakers. If you move your finger away, you can still feel it. That's air being pushed and vibrated. And that is a type of energy we call mechanical waves or sound. Now we can use this energy to do all kinds of things. Of course, we can listen to music with it, but we can send these pulses of sound and learn more about the world around us. In the upper center, I have a fish finder, which finds packets of more dense material in the water, which are usually fish. And more advanced in the lower left is the sonar from a U.S. submarine. That's a Soviet sub in the lower left. Now on the upper right, we have ultrasound, which is the same technology, but a higher pitched wave. That's why it's ultrasound. It's higher than our pitch of hearing, and it can be used to visualize, in this case, a baby in the womb. On the upper left, there's very low pitch sounds, and in the same way that a wine glass can be broken with a high pitched sound waves, kidney stones can be broken with sound waves, thus preventing the need for surgery. Lastly, sound can travel not only through air and water, but it can also travel through the earth. In the lower center, that's an earthquake. Those mechanical wave sounds can break apart things. Furthermore, those same sounds with enough intensity can cause giant waves or tsunamis, which is the picture in the lower right. Now there's two types of waves. There's the longitudinal wave, which is the type that sound is, which has compressed part and a expanded low pressure part called rarefaction. And this is sound and pressure waves. It's called longitudinal since the waves are traveling in the same direction as its compression and rarefaction. Its wave pattern is in the same direction. The other type of wave is the transverse wave. And it's traveling in one direction to the right while the wave is going up and down. This is called a transverse wave, and light and magnetic waves, electromagnetic waves, work this way. Now, wavelength means the distance between one part of the wave and the next wave's same part. For instance, from top of wave to top of wave, which is called crest to crest, or from bottom to wave to bottom to wave, trough to trough, is called a wavelength, and it's measured in meters. Now, in a transverse wave, again, could be from trough to trough or crest to crest. In a sound wave, it can be from compression to compression or expansion to expansion. Longitudinal waves have two parts. There's the part that's called compression, where all the bits are bunched together, and there is the rarefaction. Rarefaction is this expanded place where the material is less dense. Basically, in the case of air, all that air gets squished up, and all those air particles will hit something, causing what you feel is pressure, and then afterwards there's low pitch pressure, which will cause it to be pulled backward. That's why you see things vibrating back and forth. First, it's punched by the compression, and then it's sucked back, pressed, sucked back, pressed, sucked back. Compression pushes forward, rarefaction pushes back. All right. Frequency is how many times something happens per second, in this case, waves per second. And on the right, I have some flashing lights for us. The flashing lights are in different frequencies. The first is a frequency of half, which means every 2 seconds, the light will flash. A frequency of 1 hertz means it's going to flash once a second. Well, the frequency of 2 hertz means it's going to flash twice a second or every half second. The number of times the wave happens in 1 second is the frequency. And we call that hertz. Now, human hearing is based on frequency, and we can only hear between 20 and 20,000 hertz. The low pitch sounds are low numbers, 20, 50, 100. In fact, you won't be able to get anything below 50 to play on your speakers. These are low pitches. Now we're into the thousands. I'm going to stop here. Now, sound is created by something that vibrates. And when that vibrating object pushes forward, it creates the compression. And when it pulls back, it creates the rarefaction. So an object vibrating is going to cause the sound to be created. In the case of the tuning fork, as it pushes forward, it compresses, and when it pulls back, it rarefacts. Now, sound has several different speeds based on the media. The speed of sound is 343 meters a second, or 770 miles per hour. In water, it's much faster, about 5 times as fast, at 1,482 meters per second, or about 3,300 miles per hour. And in a solid like steel, it's 5,960 meters per second, or 13,000 miles per hour. The most important thing for you to remember is it's slowest in sound, faster in water, and fastest in solids. If you have any questions, please email your teacher. I'm at cmellon2@neist.net. Ms. Joyce is at jjoyce@neist.net, and Mr. Mraz is at jmraz@neist.net. Thank you.